Aloha, my name is Joel Truesdell and welcome to my outdoor lab. While I'm explaining the indoor lab, you're going to be observing the students behind the camera here as they take pH samples of the soil and the water that is here. Behind the camera is the land that has been cleared or is being cleared, and at the same time, this is going to be the extension of our outdoor laboratory. The students will be outplanting their endemic trees that they've been raising since August, and they will do additional experiments out here relative to fertility and relative to drainage. And they will continue to care for the land through the end of the year. And now for the indoor lab that you will be observing, the students will be doing the Pohopo'akai lab that was illustrated in the instructional method. This is the coolest and most integrated lab that you could ever imagine. The Hawaiian culture is integrated with the chemistry topics of reaction types, gas laws, thermodynamics, acid base, and equilibrium. The goal of having complex integration of both culture and science was stated in my philosophy. The Pohopo'akai is a traditional Hawaiian salt drying pond. The practitioners heated coral, calcium carbonate to decompose it to calcium oxide. It was then added to water to make a paste. The water hydrated the calcium oxide to produce calcium hydroxide. The paste was used to line the lava well. Salt water was then added to the drying pond, with salt being harvested after the evaporation of the water. The calcium hydroxide lining was mixed in with the dried salt and provided an antacid to the daily diet. You will observe the introduction to the lab with my period 3. This is done in a traditional manner where all of the preparation, the pre-lab, the write-up is done beforehand. And what you will see is the students just focused on the teacher or kumu. Now techniques will be shown and safety will be reviewed. The lab data gathering and performance will be observed first with period 1, followed by period 3, and then followed by period 5. Ongoing formative assessment will be observed. You will notice that I use a differentiated approach to answering student questions during the lab. If we've covered the topic, or if the student has done investigation of the topic, then I will use a standard redirect, as in, well, what do you think? But if we haven't covered the topic, like the topics of pH, acid base, thermodynamics, gas laws, then at that point, or if the student is really just still developing, I will answer the question, but I will require them to put that question and a thorough explanation into their lab write-up. The data gathered during the thermal decomposition of the calcium carbonate is a mass loss of CO2. And this will be used in a Hawaiian culture-based POGL at the beginning of the gas laws unit. The data gathered from the heat evolved during the formation of the calcium hydroxide, which you will observe when they're doing it with the coffee cup, will be used in a Hawaiian culture-based POGL at the beginning of thermodynamics unit. And the data gathered during the acid-base titration, which simulates a reaction that goes on in your stomach when calcium hydroxide is ingested and reacts with the HCl, will be used in Hawaiian POGL exercises at the beginning of the acid-base and equilibrium units. Now, from a Hawaiian perspective, I cannot overemphasize the importance of the pasting of the calcium hydroxide onto lava as the students taking part in learning a traditional culture practice. The post-lab wrap-up was observed the following day with period 5. After the post-lab, I will let you know which classes were regular classes of chemistry with students who traditionally struggle in STEM classes. We only have, the class you'll observe only has one student who's gotten an A before in science, and which ones are honors. While viewing, see if you can tell the difference. Now sit back and enjoy watching these fantastic Hawaiian students enjoy honors in college prep chemistry. This, what we need to do right at the beginning, is we're going to have to go ahead and finish up the day 1, thermal decomposition. So in which case for this guy, and we do have a bunch of techniques that I have to kind of show you a little bit about. We're using a lot of new equipment, a lot of new techniques, so that has to be kind of visually demonstrated. Now this class, I think, is easily my best class in terms of learning things in the ancient way, because I could see all eyes riveted up here. Didn't learn by computers and writing down stuff on paper and all the stuff like that back in the day. Okay, neither your ancestors nor mine. Now, do the colors mean anything?
Yeah, the pH.
Indicates to how much the acidity of it. And I have a universal indicator scale up there. You should have it in your lab notebook. Okay. Now after that, that's the only place where you're using the heated coral as a chunk. Everything after that, you're going to powder it. Okay? You want to get it down to a fine powder. As it's applied onto the lava, the finer the powder, the better the application. The bigger the chunks, the more likely it was to easily come off when the salt water was put into the drying pond. When we add this to water, plus water, it actually turns into the lining, calcium hydroxide. So we're really just looking at the thermodynamics of the formation of the lining. Okay? But this guy here, as you know, the lining of the salt drying pond, when Auntie Ku'ule explained the whole thing to me was, she said that when the salt was harvested and they would take that back, to their homes, it would be irritating to the skin. And I said, that's calcium hydroxide. It was a little irritating. So at that point, I realized that this stuff was in the salt. When that goes down in your stomach, it's like super Tums with calcium. It's going to react with the HCl. So we're going to do in there, that's an acid-base reaction. So you guys are going to do an acid-base reaction. Neutralization. Green. I'm not going to tell you what color it starts at, but you really want to get it to where when it's green, the calcium hydroxide will have all have reacted with the HCl. So that process will go on in your stomach if you're eating salt that's produced this way. Yes, Kiki?
So when you're making the paste, do you just want us to add drops of water and then just figure out?
You add it, your goal is to get a paste. Now, is there a magic number? No. And that's something that you're going to have to do to experience it. Some people will not put enough water in, some might put in too much. So that's kind of, you're learning kind of on the job.
Okay.
Okay? Okay, people, eyes up here. We're going to go over what we're doing. We're going to start with safety. Like last time, we had safety glasses and aprons are mandatory. For today, girls, if you have long hair, it has to be tied back. So if you don't have hair ties, I have some pretty nifty colors up here. Okay. The last thing you would want to do is get some of those solutions, get it in your hair. That would be bad. Okay? Now the second part is you're going to be doing heated reactions. So I just want to make sure you know all of the equipment. The equipment is, each of the lab stations has a coffee cup to be able to do the heat of reaction in. There's a thermometer over there, measuring out the different volumes. Like for instance up here, 25 milliliters of water, we have graduated cylinders over there. Okay, now down here, relative to the part where the lining actually ends up in the stomach of somebody who's making salt this way. The acid-base neutralization. This is the lining, and your stomach acid is the HCl. These are recommended amounts that you can do, whatever you came up with in your own procedure, and that's fine with us. You have test tubes to do the reaction in. The universal indicator is still over here. Some people, have say 3 drops or 7 drops or 5 drops. It's up to you as to whatever you decide. The barrel pipettes are over on the lab benches, and those will be used both for the universal indicator, but also for the HCl. And I have an Erlenmeyer flask on each bench of the HCl for you to use. Okay? Then finally, when you've gotten done with that, after you've done all of the different steps, you've done the heating, you've added water to it to actually, and you're doing the thermal reaction, heat of reaction. The rest of it, after you've done those parts, and you've also done the acid-base neutralization, the rest of the powder you're going to take and make the paste. You do notice your ancestors were great scientists. Now it's your turn. Okay. Any questions at this point? I know there's one more thing that I've forgotten, but that's okay. Safety, safety, safety.
Did you write that really quick? I wrote it last time.
See how long it takes before they figure out that picture up there on the wall.
I hate you.
I'm next. You're over here too.
Okay, honestly.
This is horrible.
I don't know they're right. It's the same picture. Okay.
Same picture.
Let's get there. Right?
Which one is your favorite?
Sounds way too much.
That's your one is for the unheated, and it's
I hate when it's like uneven.
this one is stronger.
It's like, is it purple or is it like that? It's like dark blue. Just put dark blue again. Bam!
Okay, 25.
Look at ours.
Where's the thing to record?
Oh, it's right there. Hello.
Okay, one more time. It was released, which is indicative of a
It shows that a chemical reaction happened and it's a product. Unique as a byproduct of a chemical reaction.
product.
Okay, the blend
Now,
is
you had a question. What are you working on now?
We mixed the pH and it was, we determined it was a blue, so it's a 9.
How much water is in this?
You do add the water. That was the question.
Yeah.
You add 5 milliliters of water, right? To that.
Your
It's all
choice.
together?
How much?
Okay.
You need to make it a solution.
Okay, we got it.
That's the
Okay. But record your data. You got to record your data.
writing it
Do you have data?
Yeah. So
What does
we put 10.
what does that tell you? What observations did you make? And what
That it's basic, yeah.
basic? How basic?
Like very basic.
How basic?
10.
Okay.
It's rated 10 on the pH
Okay.
because it is purple.
Okay.
It's violet.
Now, that is the pH. That is the heated coral. That would be the pH that would, of the substance that would be before or after it went into your stomach.
Before it goes into your stomach and then it reacts when it goes in.
Okay. So let's kind of proceed and show us what it would look like when you do the
So
reaction.
we measured the what is it called? This hydrochloric acid.
Hydrochloric
And
acid.
to the acid, and then we have to add the
So the proper way to do it, which we really haven't talked much about, is you add it dropwise and you have to thoroughly mix it between each drop. Yes.
with the hydrochloric acid, and then add.
No, you add the drop of each gel in there. Because once it gets into your stomach, your body motion is actually going to mix it.
10. Because we've just been doing 10 this week. So let's keep it even. 3, 4. Oh crap, that's 4.
Oh, that was close. Don't sound another one.
278.
Yeah, because it's like the thing that we did at Halloween. It's like when you
No, no.
I don't know, but it was changes. It went from purple.
Let me ask you, when I
to
put it
green.
and it's kind of saturated up here, before I shake it, could that have a different pH up here than down
yeah.
here? So once I shake it, that's the reason for shake it. You get more uniform. The stuff up here gets a chance to react with the stuff down here.
It changes to like
to green and greenish yellow.
But that's because you're saturating one area. When you shake it, then it's going to. So you're going to have to go. You have to go until that's why we're supposed to be shaking it.
so we're supposed to go until it goes to green and add as many drops as we can. Okay, we're like 30.
Because in your stomach,
Because your stomach is really
does it?
sick.
Does
Okay, that's what I was saying. We were like confused.
So we just shake it back to green.
How much drops do we need? We need this at all? No, well, we have different packets here.
Yeah.
Wait, what do we need for?
I don't know. I mean, they look all like a paste, but you're not really going to be able to tell totally until you actually start putting it on to see if it's smooth, see if it's kind of
Which one do
granular.
you want to put on?
This one. You can put it on that one. Okay. No, it's you.
It's up to you.
Okay, we can't. It's wherever you want to put it.
Yeah, no, that's fine. You don't want to use so much that you coat nobody else has any place to coat it. But you need to now pat it in, pack it in. Because if there's space in there that it's not really packed into, it would just fall off when the salt water was actually put into the drying pot.
I don't know how much it is. I just put like 4 out.
Yeah, we put so many.
Oh, that makes sense.
Mr. Truesdell, we're on like 20 drops.
Keep going. It's going to take a while.
Okay.
Because you have a lot of calcium hydroxide in there, right?
Yeah.
So it's going to go until you've neutralized it. You're reacting. You're doing the reaction.
So we're not doing it wrong.
I don't think so. What do you think?
I don't think so, but
I'm hearing like 3 drops.
Well, not everybody is neutralized. How much calcium hydroxide did you put in?
0.25.
Or calcium oxide? 0.25.
Yeah.
That's going to take a while. If somebody is not taking a while, then they probably did. Either that or they just put pH smaller on it.
Okay. Yeah, I feel pretty good about this.
So, what does the purple color tell you?
That it
Has a high pH of what? What value? 10.
Sorry, I don't have my glasses on.
No, it's not a trick question.
Just put it in here.
What did it say?
See, Mr. T, there it goes.
How many grams did you put in?
I'll keep bringing of the coral.
Yeah.
We only put the 0.25 grams.
It's only in this one?
Yeah.
Keep at it.
Joe,
Keep at it.
use the one that you had the original pH in there.
Pardon?
Whoa, that changes.
You put the stomach acid into this one.
Yeah. You just
That's the
wait,
one
hold
with
on.
the pH
You put
and
the
the water.
coral in, you put the pH stuff in, and then you put the water in, and then you do that.
Okay, yeah, that's what we did. Yeah, and then you keep adding the stomach acid until it turns green.
And you have to count.
And you have to count. Make sure you count and keep track of your drops.
Oh, and actually I said it last time. Yeah.
Wait, it's more acidic the higher the number, the more acidic it is.
The element names next to the ink.
So then, if this is correct, when we're using that, then this would be less acidic.
Which one?
The heated one.
And
Yes.
this one has neutral pH.
Because it lost acidity when it was heated.
Yes.
A little bit above.
Well, if the color changes, what does that tell you?
There's a chemical reaction.
There's chemical reaction, so the product that was formed was less acidic. Okay? But a lot of the particulars relative to pH and acid, that's Monday. We spend the whole period.
Coffee cup and then measurement temperature.
Part of it goes in there, yeah.
Yeah.
And for the other reactions. And then ultimately the remainder will go.
Oh, it would be used for paste
On the lava.
on the lava rock.
Okay. group is on it.
You know that?
My favorite saying over there, your ancestors were great scientists. Now it's your turn.
We're the ancestors. We're the future. We're the future.
And the present.
Our ancestors probably danced hula while doing this.
Yeah, our ancestors probably danced hula.
They could have. Ask Auntie P. She lives down in Colorado, right where they used to do it.
Oh, really?
Yeah.
Connections. We did the coffee and the acid. We did that already. We're just doing the paste.
Okay. What did
We do the science is fun thing right now.
Sure.
Sorry. Okay, what are we doing? Okay, so you're making the beat, and then and then we're just saying. Wait, what beat am I making?
Wait, I want to help you guys. Just because.
Ellie, you're gonna dance with me, okay?
No! That's what I want.
Yeah, okay, but don't
You see it when you actually make the
do that.
case.
Oh, wait. Because this one's
Yeah,
let me have it in the fire.
Don't drag it.
Don't drag it, Kiki. Don't drag it?
The noise is gonna.
Oh, yeah. Okay, should I do it this way? Charlie, you're not getting me.
No.
Okay, wait. I'm gonna high five somebody.
You do your science suspension.
Okay, are you
Yeah.
ready?
Okay.
Okay, when I
Ready?
Okay. One.
Okay, wait, gotta set it this.
Oh, we're doing your hula first. Okay.
Come on, Charlie, come on.
Are you ready?
Yeah, we're doing science is fun.
Haley, come on, give us a program.
Come on, come on.
Someone's go Kiki.
Okay.
Let's go. Let's go.
Okay. Science is fun! You're giving a commercial.
We should.
Okay, so explain your colors and what they mean. This one is which one? This is unheated. What's this one? This is the heater. Now, what does that color mean?
It's neutral, yeah.
Okay. Green, neutral. What else? What else? Do you have a number? Do you have a number?
7.
Remember, it's data. We gather all data. Don't ignore it. What about this guy right here? What color is that?
Yeah.
So look at it carefully, Clint. What color is that? So how would you judge that?
That would be
Violet. pH 10. Now, the fact that it changed from that color to that color indicates. You got it. Chemical reaction. Okay.
Page 10.
Reaction occurred.
pH change.
There was pH change. That was on day 2. Okay. From one going to the next. Yes.
Mass was lost.
Mass was lost. Put together. Right now, we're just going from calcium carbonate, we heated it to calcium oxide, and we're looking for evidence of that change. And the mass lost and the pH change when we put them into water and checked with universal indicator, that was true. So, yes.
It became more brittle.
Exactly. That was the third one that I was looking for. Brittle. Okay. The temperature change, not really. That one is going to be, that was a different reaction that you were confusing. But it's understandable. Okay? Now, let's take a look at the next one. Now, Emma, what evidence do you have when calcium oxide is converted to calcium hydroxide when what? Temperature change. Okay?
First try.
Okay? Anything else you can think of at this one where there's something that indicated that a reaction was occurring? Let's go to the next one, the third reaction that we have. Give me the evidences. Ashley.
Became more neutral.
pH became more neutral, pH change to neutral. Okay? Leah?
She said,
Okay.
pH, oh wait, no, became, oh, no. Okay, never mind.
Okay.
Just all in one. Oh, I know what we could have done.
What could you have
We
done?
could have monitored the temperature.
Exactly. Excellent. You extended it. You've gone beyond the reaction to suggest. Okay? So let's put extend, monitor temperature change. That's true. So we don't know whether or not the temperature changed, right? Because when you were there with the test tube and you were adding in the HCl, you didn't have the thermometer. Okay. Now, the next one. Coral is not heated all the way through. How would this affect the results? I'll let you.
It wouldn't be as brittle as if we had it
Okay. Not as brittle. Okay. That would affect the results a little bit.
The mass loss would be different.
Mass loss would be different. Very good. Okay. Let's see. Seisha.
The temperature would be different.
Temperature change would be different in the second one. Okay. Kind of spread it around a little bit more. Ashley.
The pH would have been different.
pH would have been different. Okay. Okay. We don't have quite enough time to elaborate and really kind of think it out as to whether it would be greater or less for each of these, but at least you're recognizing that it would affect each of those results. Okay. Okay. Good job.
Thank you, Mr. Truesdell.
Okay. Was that a fun lab or what?
Yeah.
We should do it again.
Do it one more time.
One more time, because last time I never know it.
You have just witnessed an outstanding Hawaiian culture-based lab that I designed. Now, NGSS Appendix D is critical in the design of lessons for Native Hawaiian, Native American, and Native Alaskan students. Now, historically, Hawaiian students have not been very successful in the pursuit of STEM careers. By me taking my lessons into their cultural world, my students more readily engage, explore, and sharpen their focus, as you could see in the Pohopa'akai lab. Now, the first group that you observed was the honors class. The last group in the lab and in the debrief was my regular chems class, which is filled with students who were historically poor science learners upon entering my classroom. Now, by me making science learning fun, I remove barriers that inhibit the explain and the extend phases. Now, the girl who was having fun dancing the hula in the video, Kiki, she has danced internationally. She's a 4.0 student, and she wants to be a medical doctor. I'm doing everything that I can to help her make that happen. I turn my classroom into a dynamic native learning environment. As students build confidence in their ability to do science, my students, they're much more likely to pursue STEM careers. I'm not just teaching chemistry, I'm changing lives. Now, I hope to see you in February. Aloha.